unfortunately home stuck from work, so doing it on a laptop. But ready to give this a challenge. Again, got some basic testing set up, how it all function here. Gonna break this into multiple soon, but shouldn't need to do anything fancy. Here goes nothing. Following notes. Okay, so it's multi-line string. That trim, love it. Words. Sentence contains four runic words highlighted, and other examples of the same words. Count all the runic words from the description. So these are all the words, and this is the thing. Okay, so this is my input, not the entire thing. Okay, so words equals this. Da, da, da. Should have just kept it as a string and split it. The possible the al mesrad her. The oh, it's just if the sentence contains it literally. Okay, great. For cast word of words. Input, nope, input, split, in the space, if count equals 0, if input include word, plus, return count. Let's see what this is expected. This expected is 4. Nope, I got 3. The power, the flames. That's total count, not just includes. Okay, so it's input split word dot length minus 1, I think. Count plus equal. I think that's how you do that trick. There it is. Give me my note. Run that. Oh, geez. Oh, the words are changing. Oh, great. So words equals words dot split, comma, which means these words were actual words. Drop that there, drop that there. Quotes there. Sure it is. Just ignore that TypeScript. Put that there. That is our second argument. Which goes way over there. First gotta make sure this change works. Still does, it fails. 32 apparently. Good. Part 2. Okay, I'm not saying what's different here. 15 runic symbols, 9, 6, 7. It's just split over multiple lines. I don't see the difference. Oh, right to left or right to right. Okay, got it. Let's solve quest 2. So words for const word of words dot slice to make a quick copy of the array. And then words dot push word dot split dot reverse dot join. Exact same thing, but solve quest 2. Give me the inputs. It'll give me the real input, which is this multi-line string. So that did end up coming in, not trim words. Okay, what's it supposed to be? 37. See if I got that. I did not. 13. Okay. Counting the runic symbols that make up the words. Okay, there we go. Count word for const word of this count length. That's multiplied by this. And then it's word, not found word. Drop that, do that. Rerun this. 3759. Dang it, went too high. The 15 symbols. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Ooh, it's unique per line. Okay. For cost line of input split line. What symbols this line equals new set, and then search in both directions. We got that. That part goes up there. Chord and line symbols this line dot for car of word, add characters, then count plus equals the size. See if that is what I want. 37, 36. A little off by 1. Did I lose? Do anything? Okay, I need to see how much here's per line. Console log symbols this line. THERE7. Let's run it. 9999. Let's coincidence we hit that because there we go. Line. Const line of this for word of word for car of word. I need to actually check if it's in there. If line includes word. I think that's what I want. Obviously lost some logic here. Dang it. Whew. Off my game today. Okay, so for every word, the line includes the word, symbols this line. Let's see what we got here. The THEOWEDORTHE. It's counted twice. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. What am I doing? 15, 9, 6. I don't see what's going on. I have lost the sauce here. Man, I really losing it. Okay, 1, 2, 3, 4, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. 15 symbols. Okay, for word of word, if line includes word. For char word, this needs to be count, which is like this. For let I equals 0, I less than plus plus. So do this that many times. Dang it. Okay, for each word that's found, got 2 those. How's that input line? Jeez. I am really trying. Um, 4 equals not that. Count. What the heck is all words doing? That's doing nothing. Log count minus before. Let's see which one's the problem. 15969. THER. Oh, REHHER. There's overlaps. Dang it. Okay. Um, symbol indexes, new array, line length, fill is 0. Okay, basically you check if it equals and then flip them all to ones. For const I 0, I less than plus plus, const sub equals for const word of words. Nope, not there. If font size equals word, then yep, set that to 1. And count plus equal all of the ones that are like that. Cannot read undefined split. Why is that throwing at me there? 37, good enough. Copy, both are here. Words, grab that one. Second string, paste. And the rest is here, cut, paste, with multi-line string, dot trim, watch that run, fail, of course, because it is not 555, but is it? It is! Whew. Boy, I am struggling, but apparently everyone else is too. Quest 3, same words. Oh, we're going vertical. Heck no. Oh, this is horrible. Should have saw this coming. Drop that. Go for the backticks. Dot trim. Give me. Nope, don't give me mine now. Count the number of scales that compose them. Hold on. Right seamlessly connected to the left. Unbroken loop. Horizontally and vertically, top to bottom. H E T H E. Oh. W. Okay, I see. You just kind of highlighted symbol runes, whatever. Okay. I can do this. Gonna collapse you really quickly, buddy. Solve quest 3. So what I need to do is basically double the universe to the left and to the right. Or I just do a grid-based system because I need to look at every position and search in every position in every cardinal direction with wraparound. Yeah, okay, so basically we need to turn this into a grid. Let's copy the real. Okay, it is a square matrix. That's at least usable. Const world, or yeah, const world. Congratulations, it's a thing of this. And for const or L 0 R less than both inverse and right verse. Yes, yes, yes. Input dot split new line dot length. Let's grab this. Say this is const size. size for let C equals 0, and then let's build this up. Yes, so that's going to be world R equals world R or thing, world R C equals, oh, this is character, so that is lines equals input split. There we go, which means I can move that up. The size can be the lines length. Lines R C. There we go. So now to go through every coordinate, every index, and every direction. So for let R equals 0. Yeah, gonna do that again. Drop that, drop that. And then it's for every word in this position, for every word, for every cardinal direction. I can see my optimization going in the trash can, but we'll see if I can spot this. Word of words for constructor of, I guess I have to calculate all the directions. 0, 1, 1, 0. Excuse me. 1 cardinals, so it's negative 1, 0, and 0, negative 1. Okay, so this is RO, CO. There we go. Row and column velocity. So what I need to do is const of letters equals this. I actually need to do const chords equals this. And it will be for, dang it, why is Copilot on? Apologies. Get back off. There we go. I equals 0, I less than length, I plus plus. Well, first, we have to make sure the first one is good. If world RC not equal word, boom, free optimization. Now we get to go in any direction. New row equals R plus RO, cost NC equals R plus C plus NCO. Let's make both of these lets. If NR greater than or equal to size, NR equals 0. If then NR less than 0, NR equals size minus 1. So technically I could just do an equality check. That'll never happen there. Do the same thing for NC. I love it. So they all wrap around, do their thing. And I won't need to do this. I'll just mark them if I hit them all. Let failed equals false. If world R, oh, NR, C triple equals word I. Excuse me. Failed true. Break. Not failed. So I should correct the chords. Chords equals right here. RC chords. No. Push R or NR and C. That's right, and they have to be, they don't have to be that. That offset amount is good. Well, it's not going to let you keep moving around though, so let nr equals r, let c equals c. There we go. I could also do multiplication here, times I. Let's actually do that, times I. There we go, like that. Hopefully, if the operations are good. Failed for const chord of chords. Now let's make a const scales for same copy. That's going to be Boolean states. Scales equals 0. Scales, well, I'll break this up into R and C. R and C equals 1. For const row of scales for const slot of row count equals 0 if slot scale count plus plus. Scales is an object, so that's why we're not going to get that. Values, scales, that one can be keys of values, which are more things. Okay, what are rows? Rows are unknown. Scale is an object. Dang it, that's not how types go. There we go, it should be enough. Is that good enough? Okay, good enough. Return scale count. Now let's see how efficient this bad boy is. This apparently is part 3. I typoed that real good. Undefined 0. We left nr and c size. Let's fix this off by 1. So nr. Somehow we want above. It's supposed to be 3. Okay, let's get row code. Let's get that again. Okay, so we went to 0, 0. That's great. We went to 4, 0. So I went less than 0, and we hit the size, -1. What happened? Let's log it before. Well, it's kind of hard to do before. Let's maybe need to drop these. I don't think we would. Still the same. Okay, okay, okay. Let's put manual loads. See where we're going wrong. So we generated as a 4. Okay. So R plus that many times. That makes sense. Okay. That means since we're not doing 1 by 1, we can go above. That's on me. Drop all of these. Hopefully that's all needed. 3? No. 10. What happened? 3. What happened? R, C, for word of words. Wait, right is always seamlessly connected to left. Okay, that's actually going to hurt me. So the rows cannot go around if, which basically means these are both continues. Doesn't really change anything. If anything, I'll get less now. I got more. That makes absolutely no sense. Um, Maybe my world was not generated correctly. The risk of not using a matrix. So 0, 0, H, 0, 1, E, 0, H, E, L, E, N, I. I've lost. Dang it. It's not a square, it's a rectangle. Okay, so count equals 1, count equals, there we go, drop that, row count, row count, row count, row count, and now we have column count. I love it. Absolutely loving it. Now, this might be it. 10, 14. Okay. So what I want to do is scales, output that. It's actually horrible to look at. Okay, I'm going to go through the lines and modify them. For let I r equals 0, r less than row count, plus go for let's see 0c, steal that loop, go if scales are c, line c equals, I guess that'll do. Okay, let's see what that can output for me. That's horrible. So we have that. I'm seeing the override. LW, NIG, HET, HE. Why are those two getting hit? They shouldn't be. K somewhere there. If the was not one of the words, what would happen? Yeah, so the is doing the N. I'm not seeing it. T. Okay, I need to find basically all of them. So if I put this, I'll see all of them. Chord. Nope. Now let's see what we have. Now what I want to do is start with the coordinates. Let's not look at those. Okay, so it's 001020. 2, 3, 4, 5. Do I have any 5-letter words? Okay. It's a 3-letter word. 1000. What 2-letter words do I have in this universe? Okay, let's log the word. Dang it, this continues. Come on, true. Yeah, you go off the reservation. You are failures. Okay, I think this might be output extra logging. It is. I have to drop the logs. Drop the outputs. Drop the logs. Drop the logs. I think I have enough for the real input. I did not. Copy this, paste this. This is my matrix that is not a square. Love it. Where are my words? Here are my words. Dang, there are literally 1-letter words in here. What intonation? What does that even mean? 12403. Let's see if I'm lucky. I am. Okay. Whew. That was a toughie. Still doing okay. Whew, boy, what a drop off. Okay, I made it. Unfortunately, I will not be cleaning up and polishing right now, but I think this will be a fun one to actually visualize. The matrix, all that fun stuff. Again, not visualizing it now. Not visualizing it now. I already said that twice. Not polishing it now. Gonna do that when I return.
Hello, hello, hello. Back to clean up and break down the second quest in Everybody Codes 2024. We knocked this out technically 2 days ago, I believe, but did not have time to do my cleanup or explanation. So I will be doing that now. This is the exact code I solved it with, very raw and unpolished, but good enough. So let's break down the actual problem here. So this is the, I believe, first notes or input from Everybody Codes that has 2 distinct sections of it. The words, which is a comma-separated list of words you should search for, and then the text you should be searching for these words in. Now, the initial V1 or part 1 was to see if the words you are looking for were simply contained in the text. What is this? The inscription? The inscription, right? So, if the runic words were in the inscription, just straight up, and to count the number of runic words in the inscription. So that one was accomplished here, first by taking the words and the word string and splitting them back into an array, then counting how many times that word appeared. Did do a little bit of fanciness here, or a little bit of laziness, by taking the input inscription, splitting it based on the word, and counting how many resulting strings are outputted. This can be more easily represented if I were to debug it out. So let me hit that on the example. Nope, not there. Quest 1, there we go. Nope, come on over there. Here we go. So we can see we're looking for the word of the. So if I drop that in the debug console, you can see it splits the string delimiting on the. So you have awaken, power adorned with, flames bright, ire. So the thes aren't actually visible here, but we get how many strings, well, we get the strings that are on the left and right side of the thes effectively, which means that since there are two thes, we can take the number of strings that we get out of this and minus one of it. That's the simple trick that's done here to effectively count how many substrings exist for this particular substring. Not the most efficient because we're creating this whole array in memory, but it suffices. I believe the next iteration, right, count the runic symbols that make up the shield. So not only we're not counting words, we're counting characters. We can search in both directions. So it's the and EHT, for example, are both things you want to search for. Multiple lines. And then I believe the last trick is that if a character is used in two different runic words, those characters don't get counted twice rather. First thing, I generated all the possible words by going through the words and just adding their reverses. So we can see the impact of that right here. Part 2, debug. Okay, where are my words? Drop all these small ones. There you go, so you can see all the words, and then eventually there's the middle of the array. So the first 5, and then the second 5. H-E-H-T instead of O-W-E-E-W-O. And we just did that in this loop here by going through all the words, a new copy of the array using that slice, so we weren't going on forever because we're modifying the thing we're iterating over, and then splitting the word into an array, which you can dot reverse, which then you can do dot join to turn back into a string. And then we do the next bit of logic, which is going through each line and seeing which characters or which runic symbols, well, which symbols, I guess, are runic symbols. So the trick here, just see if I can see a visual example. Okay, here's a good example. T-H-E-R. So this is made of T-H-E and H-E-R. But you can see we only count 7 symbols. Usually you'd be like, oh, so we have T-H-E, so that's 3. T-H-E again, that's 6. H-E-R, that's 9. But since this the and this her are overlapping or reusing the same 2 characters, we don't want to count them twice. That's the next implementation or the next challenge of this part 2. Don't count them twice. So the way I went about that was for every line creating an array of indexes of, hey, these are the symbols that are runic and that we're going to use. And then for each of them, so I no longer use the old split trick to check, hey, is this one of the runic words? Instead, I effectively create a pointer iterating through each individual line. So we can say my pointer is pointing at the T, for example. And then it goes through every word and it says, hey, if a substring of the word length, so I'll use the, so starting here, get a substring of length 3, which will be the, does this match the current word I'm looking at? the. If so, then I want to mark all of those indexes in memory, which is an array of 0 or 1s, as 1. To be like, yes, these are runic symbols. If I represent that as a comment, it would look like a bunch of these. So then once that was detected, we'd be like, there be runic symbols. I'm going to remember that for later. And then we would go through, probably inefficiently, the rest of these. None of them would match a substring length of 3 at that position. We would move on to the next one. So looking at the H, and then since it's length of 3, the next 2 letters, her. Nope, the doesn't count, this doesn't count, this doesn't count, this doesn't count. And we are still doing the inverse, so EHT is also being looked at. But then we find her. So we see that the substring of length 3, starting from the 1th index, does equal the current word of her. And we flip all of those to 1s. So we flip these 3 to 1s. 2 of them, however, already are 1s. So we just flip 1 to 1. And that is how we avoid double counting the individual characters of the line. I think the next 3 are 1, 2, 3. There you go. I think that's it for this example. So that's 1, 2, 3, 4, 5, 6, 7, which matches up with what we were supposed to calculate. 7 right here. Then we add to the count the number of 1s, which is easy because this is an array of numbers. We just reduce them away. Again, proficiency is not the best, also not the worst, but it works. Talk about optimization later. And then quest 3. This is where I think this one spun me around a little bit. The trick about this one is that we're actually looking at the representation of apparently a scale armor. So imagine this is torso armor, and that the left side is connected to the right side. So this is effectively a cylinder. We're looking at a cylinder where the top is the hole of the cylinder, bottom is the other hole of the cylinder. The rights are connected to the extreme lefts. This is a wrapped piece of text. And also, we get to look in any direction for a word. So you can see OWE is being found vertically. Not diagonally, though. So they didn't make it that difficult for us. But you can see the THE was only found via wrapping around. The rest of the logic remains the same. You're counting the symbols that I'll make up the word so you're not double counting. You can see we have rodeo here and OWE here. The E does not get double counted. I'm trying to remember what I did here. Okay, first I converted all of this into a coordinate grid. So I just use a dictionary to represent the rows and the columns, or the X's and the Y's. Then I created an identically shaped grid for which ones have been flagged as scales or not. This is the same formula as my array of symbol indexes, but it is two-dimensional. Then, yeah, I went through all of the words, and again, this is a very brute force solution. I then determined where the words can be found. So I started on H, and I grabbed all the words, and I'm like, okay, do you start with the letter I'm on? No, none of you do. So I'm going to go to E. Do any of you start the letter I'm on? Technically, the reverse of the does. EHT. So I found EHT, and then I started trying in every cardinal direction. First, I went up. I was like, nope. I immediately went off the scale armor, so you can't be in that direction. Then I went to the right, matching character by character of the word I was looking for to the character I'm seeing. EL is not matching EH, so I stopped looking that way. Then I look south. EN is not matching EH. Then I look to the left. EH is matching EH. So great, okay, the loop continues. Now I'm at H and I'm looking for the next one. Now, you can't change direction when you're doing this. So once you have a direction, you just keep going that direction. Going further left takes me technically out of the world, but I believe I have logic here for if my column takes me too far left, it wraps around to the right, too far right, wraps around to the left. And then we have the exact same check that I was verbally describing. Hey, if you don't equal the one I'm looking for, then you failed. But if you make it through all of these, we're going to keep your coordinate for later. And then if we never found you as failing, then we're going to go through all your coordinates and say, there's a runic symbol here. Remember that. The last bit is simply counting up all the runic symbols that we flagged as good and saying and returning the count. I don't believe any of the code I used was too ordinary or out of the world here. Here's the first character check that stops the whole process. Here is looking in every cardinal direction with offsets of row and column. We start with the first one because we already know the 0th one is there. We calculate our new row and new column by multiplying by how many we've got out. Yeah, if we go below the scale armor or above it, we instant fail. The wraparound logic I just described for left and right. If you don't find the character you're looking for in the next word, get rid of it. Otherwise, keep them. And if you haven't failed, go through all the coordinates you remembered. Set them all to true. Yeah, nothing too advanced here. Yeah, and that is effectively it. And then I have all my test cases hanging out down here. I think this is going to be a pretty fun one to visualize, honestly. Because, well, it's a very visual problem. But we're not going to jump into that. We're going to jump into what would be the refactor. So how would we clean this up, make it a bit more better, a bit more reusable, all that fun stuff. Let's first look at quest 1 and quest 2. So one's just counting the words, the other is counting the unique symbols in the words. The third one is doing vertical and left-right wraparound. So those are effectively 4 features. Of the function. So I'll start by making. What are we doing here? Number of runic words, number of runic symbols. Okay, so returning words and symbols seems to be the output for all 3. So get count words, count symbols, get runic counts. There we go. And then what is this input? I guess it's inscription. So it's inscription here. And we have a shield. Inscription, inscription, inscription. There we go. Runic words. You know what? Let's inscription with words. There we go. Well, words and inscription, because that is how our input comes in with both, and then we'll have to split it off. Alright, so the first conditional kind of logic is vertical counting and wrapping around. So, look vertically. Thinking of how I want to describe this. There we go. Wrap horizontally, search vertically. Okay, I like that. I like that. Then what we're going to need to do is separate out the words and the inscription. So I believe this is words equals words and inscription, where we split it based on that blank new line. Whoop. And we split that by one and the rest by commas. I believe the inscription is just the other side. Of the blank new line split. There we go. So now we have those parts from the original input. We can start doing the bad stuff. So I think I'll copy it from the latest implementation, because that's the one that can be easily modified to satisfy all. And then we'll go for simplifications after. Let's see. Let's say whole lines equal inscription. Nope. Inscription split on the new line. Then I should be able to calculate row and column count from that like before. Yes, I can. There we go. Then we generate the world, the scales. We're also going to calculate let words found equals 0. So we're not just looking for the symbols, we're looking also for the words found, because part 1, I believe, targets that instead of symbols. And yeah, gotta get it working before we get it pretty. So we have that. I believe this logic comes straight down to, man, this logic just take all part 3. There's a reason it goes third. There we go. We have all of that. Now here's where our search vertically bit kicks in. So let's just do it here. Search vertically, we do this one, otherwise we do this one. Again, bad code, we'll make it good later. So if we search vertically, all of the directions. If we're only searching horizontally, this is my row, this is my column. So I don't make changes to my row. Don't make changes to my row, only change to column. Good. I like that. And then we have our wrap horizontally. So this is our logic here. If we're allowed to wrap horizontally, then let's do some horizontal wrapping. Else, we're going to need to do the exact same logic for here. If you go off the edge, you fail. Again, let's make it work, and we'll make it right, and then we'll make it pretty. Good. Okay, and then if you don't fail, then we find all the things, and words found plus plus. You found another word. I'm feeling confident with this. So, scale count. Means scale count. We're still counting the same thing. We're counting symbol. So, symbols, scale count, words. What did I call that variable? Words found. Again, all the great variable names. And then based on what we're looking for, we will parameterize accordingly and either return or care about dot symbols or dot words. Let's start with the easy one, a quest 1. And let's actually get Walby in here to help us a little bit. Okay, and let's stop just, get run count. I'll need to reconstruct my input there. Yeah, let me go grab the actual input. Boop. Let me in there. There, dot trim, that's what we want. What's my second argument here? This is the part where you would help me, but that's fine. Search vertically, no. Wrap horizontally, a no. And then we want the count of words. No? Expected 5 to be 4. Oh no, I'm counting too many words. Okay, well let's break this one down. Which means I'm seeing the word too many times, which means I'm hitting this one too many times. Interesting. There's no vertically to search, so I don't see that being an input. Let's make sure all of our things were generated correctly. Let's see, inscription. Those are the words. I didn't do the backwards words, did I? It's not actually a concern for this one, but it will be for other ones. Actually, I did do the backwards words here. Ah, that's the trick. So search vertically, wrap horizontally. So effectively, I imagine we're hitting another word here. If I were to look at the coordinates and turn them back into things. Chords map C, world C0, world C, well, not world C1, C1. The owl rod, the mess. 24, 5. 1, 2, 3, 4. Interesting. Okay, let me actually look at the coordinates themselves. Ah, geez, I forgot how not friendly this would be. 7, 8, 9, 12, 13, 14. Okay, I'm not seeing any overlap, so we just found 5 words. Oh, I didn't realize there were other examples. That's nice. 4 words. The owl, the mess. The owl rod, the mess. Why is rod? My eyes do not see. Okay, so 0, 1, 2. It's the second one. 0, 1, 2. Aha, we went backwards. Okay, so that is simply a conditional of, are we allowed to go right to left or left to right? So we have search vertically. That's great. Search backwards. I think that's the logic here. There we go. And yeah, this direction is gonna need to get overhauled a bit. Let's drop that, drop that. I'm confident in my solution or my fix now. Let's get rid of all these. Const search directions. That's what gets generated. Search directions. We have all of these lovely directions. Yeah, let's just make a single array. This is left and this is right. Yeah, so these, hold on. Let's just make it an empty array. We'll build up to it. Yeah, so we always start at least going left to right. So our first one is don't change your row, you go forward. You're gonna get that no matter what. Now, if search vertically, let's do the easy one. If search backwards, then search directions dot push, you get to go the other way, -1. And if search vertically, search directions dot push, both up and down. There we go. So those are all of our search directions. We define them once. We don't need to recalculate them. It's also a lot easier to read. We'll implement that extra one here. So when we get runic counts for this implementation here, do we want to search backwards? No, we want to go one direction. And it magically starts working. Not the best interface, but it works. Now let's test with our real friend. Let me get all of the words from the copy. Yep, I'm just going to use what I found in that clipboard. Drop that, da. Let me get the dot trim on there. And paste. Yep, that should do the trick. And false. You know, in here I'm going to define effectively 3 functions, which are just abstractions over these for actually solving 1, 2, and 3. Unsolved quest part. I don't usually put the word pet quest in there. Part 1. Return get runic counts dot words. And this one just straight takes up the word and description, passes it through, and then falses all of these. So now we can just use solve part 1 for our part 1 code, not worry about all the booleans. Do think we have an extra arg this line. There we go, all our hard-coded words. And expected 32 to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 0. Oh, I never put the real number in here. Well, that's on me. Make sure, yep, it was 32. Great. That is working. Now, let me write the solve part 2 and 3 ones. And if I'm correct, I can just plug these baddies in. So, part 2. We search in both directions. And we're counting symbols. Okay, so symbols. We search in both directions, but we're not looking vertically or wrapping horizontally. Correct. We're still doing symbols, and I think all 3 of these true. Let's see if this does the job. Still gotta fix the inscription, but we will get there. Grab that. That. Drop that. Looking happy to me. Let's go grab the real one. Yeah, I'm gonna have to shove these off into their own file shortly, because this scrolling is not Very fun. I shouldn't have decided to scroll on this one. There we go. Drop the extra words. Looks like I did get the right number here. Okay, yeah, I'm not doing that again. Solve part 2. Something wrong here. 1432 would be 1553. Did I? Part 2, 5225. That's what you're supposed to be. 5225. Okay. My code ain't doing the job. Or I sent the wrong arguments into it. So yeah, for part 2, keep that going on. Thank you, please. We have the words in the inscriptions. We are searching backwards. We're not doing vertically. We're not wrapping around. I'm going for the symbols. Okay, we got a problem. I missed something. I missed something that the example I did not miss. Which is never fun. So let's focus on this one. Let's first go to what we're returning. Yep, that's the number coming out. Okay. Let's make sure our words. Let's start with these ones, because this is where it's been fighting me at. So yeah, you go forwards or you go backwards. That's all you do. Now this is the one where I simply had it inline, like I didn't create a world for my part 2 code. I can see that being problematic. You go forwards, you go backwards, you find them, you don't wrap her horizontally. So if you find yourself going off the edge, you fail. If you don't find it, you do. When you do find it, you say you find it, you put it in the scales. Okay, I'm curious to see what the scales are. First, let's just look at, make sure these all appear valid. They're all one length. Oh, is this the one with words where you don't, we have some single character words? Okay, I might not be handling single character words. I mean, I'm seeing them in the coordinates, which would imply I am handling them. Yeah, and I am handling reversals by not needing to create one, just searching the other direction for them. So I don't search for dbx, but I search for it in both directions. So I search for dbx going left to right, and then I search for dbx going right to left. So that should handle my inverted words. Yeah, I'm seeing all the single words come through, the doubles, triples. Yeah, they are all on the same line, so we're not doing any vertical searching. I'm not seeing any wrap. I'm seeing the backwards searches happening. 5, 9, 6, 8, 9, 8, 8. Okay. 0, 2, 0, 2, 0, 3, 0, 3. Okay, so there are a couple ones that are getting hit twice, which is going to hit our words found. Okay, I'm curious to see. Actually, I left this thing around. RC. ZZHHH. Why is the same one being shown twice? So that messes up our word sound, but not our scale counts. Same coordinate. Same thing. What word are we searching for? ZZ. Okay, well, we don't need to be searching for all these words. And where the heck did half of my words go? Okay, I'm not seeing them. I'm only seeing the ones that are successfully found. I'm gonna look at my words again. So I could just throw a set thing on this to get some free efficiency. I'm gonna kill all these duplicates. H-E. Okay, so I say one E. There are no duplicates in here. Why am I seeing all the freaking E's in the world? All the Z's, H's, and E's. Is there even a Z? Okay, there's the Z. I think that's where I get to dig into. I guess, yeah, we'll look at R, C, and look at them too. Let's look at all the things. Yeah, so 0, 2, 0, 2. So it's both directions. R-O-C-O. Maybe that's what's getting me the duplicate checks. I'm searching in multiple directions for the same single character word. Okay, there it is. Yep. Okay, so that's kind of like an easy check or a base condition of, hey, if you're like one long, don't double search these. Not necessarily, I don't see why this is causing the problem. Though it is concerning, I don't see anything but single letter findings. Though I did see multiples before, so did I kill Wallaby? Like, they were here. Okay, let's start with these easy ones. Basically, we just don't want to double search these. And these single ones, do we not want to try and enhance this to also not double search others? Basically, this is generating the coordinates and saying, hey, if all these scales here are 1, don't look at it. That'd be almost as computationally costly as just doing the search. So what we're effectively wanting to do is saying, hey, at this position, did you find this word? If so, don't find that word again at that position, because that's making this number really bad or inaccurate. I'm trying to think if it's... this does affect multi-character words, because if you have THE and 0, 1, 2, and you're like, hey, I'm here, and I found the... And then if you're over here, and you're searching the other way, because of course you're searching horizontally, you're going to find H-E-E-H-T. Hold on. Am I properly... So I'm searching backwards, but the word is always the same. So I think that's where I lost this. Let me... Because everything I found was just inefficiencies. So let me try to just duplicate my word set. None of what I found explains why we're not getting the right answer. Let's bring this down over here. You gonna show me? Okay, so we duplicated our word set. Lots more words. Still failing. You tell me why? 1432, not 1550 something. Okay, let me look at the part 2 that really works. Yeah, we just count all the symbols that are ones. We check if it's the thing, and if so, we flip them all true. I'm curious for what word we are finding, because I'm not seeing a lot of it up there. I've already changed my thing here, so solve Part 2. I can modify solve part 2 really quickly to point to the other one. Solve quest 2. There we go. Split into input, split into words. Top equals words and descriptions. Our favorite delimiter. Then calling that bottom, and then top split that forward. Should get me running. Can I read properties of... Okay, there it went finally. Okay, let's have a lucky loo here. What word do we actually hit? It's all the single characters. We do get Jeb. Oh, let's continue that. We get BP, we get Jeb, we get PB. We don't actually get any of those super long words it gives us, but we do get words. Okay, so let's see if I at least get those words showing up. That'll allow me to help a little bit. Yeah, we don't get any 2-character words. Okay, so obviously you don't love me. But I will figure that out after this break. Whew, sorry. Okay. Yeah, they're not being detected for whatever reason. In the example, they are working, which is funny. Not the cool funny, the unfunny funny. So something is failing them. So we start at the initial character, and we look in all directions, which is currently 2, a left and a right. Let's see if the world got constructed correctly. It's tough because we're looking at the real one, not the other ones. 6, 8. So I need to look with my eyes and find an instance where this one should have worked. Right, so I saw Jeb. There's Jeb. Look at Jeb. Jeb's great. Look at all the Jebs we're getting. And all the 15,000 lols, apparently. But I don't see any Jebs showing up here, do I? No, I don't. Okay. Jeb is a word. Let's make sure Jeb is a word. Boy, let's make sure Jeb is a word. No, give all the words. There's Jeb. Okay. So I just want to see everywhere where I hit a J. If word if word equals Jeb. Let's see how many Jebs we search for. It's probably going to be all of them. This probably isn't that useful. Huh. Okay. How many words do we search for? What do we start searching for? Yeah, so basically everyone where we see the beginning. Now is Jeb in here? Row count, column count. There it is, there it is, there it is, there it is. This is not a square, it is a weird shape of things. Ah, got it. Okay, that was the problem. Why did that work on this one? Because I went for the 0th one, which is the largest one. Ah, okay. It's a... I forget the technical term. It's a matrix that doesn't have equal length rows. It's an easy fix, thankfully. So our wall generation is trash. Our scale generation is trash. These are all trash. These need to be per column. So you don't get a column count. You are just winging it. So this is lines r dot length lines r dot length, lines r dot length, drop all of these. My console is going to die and eat me alive. Maybe keep that one. Yep, you don't get column counts because this one decided to be all fancy. This is tricky because you'll need to be on the column you're looking at. So, not this row, but the new row. Yeah. Wrapping vertically, searching vertically is probably going to be a challenge for this one. But I see a bunch of green, which means it's working now. So I'm not going to worry about it. I'm going to see if I can drop this because I feel like I shouldn't be able to. Yet I am. Not going to worry about that. Let me unfocus this. And everything is green. It's always one little thing. Okay, part 2. Great. Let's head up to part 3. And then I'll get rid of these old functions. Boy, let's be scrolling. Go steal a part 3 example. Boop. And boop. Pop, pop, pop. Solve part 3. Expected 7 to be 10. Okay, we're already off to a great start. So this is supposed to do all the things in all the directions. And it won't. Okay. Focus. Don't profile. Focus. So apparently, I'm returning too few symbols. Which, if anything, I thought it'd be the other way. But let's see our search directions, because this is the main thing that changes. All of the directions. Yep, that's what I anticipated. Let's keep going, buddy. Okay, so let's turn this back on. What are all the words that we find? O, rod, or rodeo. O, rod, rodeo. What happened to the? Why do you not vertically wrap around? You were specifically told, hey, wrap horizontally, buddy. So we hit these. We do go into here. I can see my reds. Okay, so let's do a before and after. Thankfully, row count is square. What's the deal for that? Hey, I put logs here. You gonna show me? I'm not even using you in multiple places yet. Fine, I'll just do these. Oh, is it that many numbers? I haven't even used you in the next one yet. Why are you chugging? Oh, here we... Doesn't look like numbers. I mean, NR is already valid here. Let's simplify this a little. Hey, buddy. Just look at this one. What am I looking at? Give me my numbers. Okay, I think Walvy's gonna retire for now. Let's get Jess back in our equation. Yeah, part 3. Oh, jeez, hate scrolling back this thing. There we go, part 3. So all part 3 to do the thing. Put a breakpoint. So we're not going to get too far. I can do it only, though. That'll count. Give me my only. Then I can. Oh, we've still got a lot of these. Stop, stop, stop. No, my turn. It's gone. Kill it. Okay, finally killed it. Then run test 02, please. What am I console logging? Oh, console logging this. Why are you running part 3? Come on, V-test. Why are you running all of these other ones? Where's the thing? Oh, -T. Sure. There we go, find it. Okay. Whew. Well, why? Does it not go by directory name? Okay, great. We failed. We are. That's not the one I wanted to run on. Okay, I don't have unique names for these because they're just unique file names. 2402. Will that give me something? Okay, finally. Now let's wear my console logs. I got rid of them all. Okay, back to the board. And R and C. Let's see what we get. Let's do the basics. Let's just look at these. How? Come on, tools. Do your job. I see why my code's not running. I see why my code's not running. In the wrong code. So, it was me. Much apologies. I was the fool. Look at that, it's working now. Crazy how it works like that. Okay, let's see what we got. So we have all of these ones. They look great. Someone hits a -1. That's unfortunate for you, buddy. But yeah, this. So let's look at that -1. What index are you? Boy, you're a lot, aren't you? 2 -1. So it's 1 2 2 1. 1 1 2 2 1. Here we go. So -1, you flip back around to the 7. It's kind of what I expect you to do, given this input is what? 0 1 2 3 4 5 6 7. Yep, I expect you to wrap back around there. Okay, so I need to search for the word the being searched from 0 1 2 3 4 5 6 7 7 0. Okay, so if RC70, if R equals 7 and equals 0, just for all of them here, but I just want to see. It's the other way. It's C and R. Just swap those. Yep, we search for the, because that's the only one that matches here. Okay, good. Let's put a breakpoint here. Because that's what I really need to follow through. There we go. What the heck? Just let me debug this. What? Incarnation. Oh, did I turn jest off? No, jest is on. What? Fine. The runner's being weird. And you didn't do. It's all on fire. Oh, jest turned on. What the heck? Okay, great. Nobody cares. So we are looking for we're at this position. 0-7, you're gonna go 1 forward and which direction? Boy, what direction now? Yeah, so you're going forward. This is actually the direction you want to go. So you're gonna succeed. Yep, your new column is on the left. Great, it's the thing. You're looking for H. Oh, there. Oh, the wraparound doesn't account. That's right, because it's calculated, not derived from the last position. So I'm going to look at the 0th position again. So this doesn't need to be setting. This needs to be setting plus difference. It needs to be doing math. So NC minus. So let me just do the math right here. See if I can find it out. So NC is 9. If NC were 8, it should be 0. If NC is 9, it should be 1. NC minus. There we go. So NC equals. So NC, can I do negative equals? Yes, I can. Negative equals the thing. And then I should be able to plus equals the other way. I don't know, I'm not running on that example. Hey, it's green again. Love it. Let me scroll down there. Let me scroll back up through this. Okay, and this isn't working because we're not targeting the third. Did I not put the number in? 12403. I did not. 12403. That would help. Okay, let's put the real one in here. Let's go get the copy. Come on. There we go. Drop that. Drop that unlinked second parameter. 12403. Green for me. Hey, there we go. And yeah, this is a fully functional. Get out of there. Okay, good enough. And yeah, as not console log, might save a few cycles. I don't know, crazy idea. Let's see. Yeah, from 1,000 to 400, that would do it. So yeah, this is what works. Lots of room for improvement, but broke it down to one function, which I personally lack. I'm gonna make sure that third one is properly called part 3. There we go. I fixed that typo there. Yeah, like I said, far from efficiency, but it is functional. We can half our memory by just, well, it wouldn't half our memory, it would make it easier to manipulate with by having our world contain whether it's been marked as runic. this memory usage can't really avoid. Even if we did it like for the second part, we're still making it and throwing it away per line, so we're still going to get that. I do believe there are a lot of inefficiencies here with researching the same thing. We've already seen that on the same one length and two length and reverse lengths. But it's functional. I'll leave optimization for the future. As for visualization, would be a beautiful one to visualize. Especially the searching algorithm itself. Show off how that works. But I will leave that for later. If I wanted to make it a little more efficient now, I wouldn't research or double search things that have already been marked. And I wouldn't double search the same word in multiple directions if it's a single. But I will not do that now.